Hi, Amy. How are you doing?
Hi, sir. Yes, I'm very well, thank you. How are you?
Good, very good. So today, what do you want to do?
I was thinking if we could do like kind of a similar thing like we did last time, kind of looking at exam questions, reviewing them, maybe looking at different methods of trying to answer the same question. Because I find like, let's say I know like a method to do something. Sometimes in the exam, for some reason, I can't get through with it or it's not working. Maybe it's weird numbers. So just having so many alternative methods will be like really helpful, I thought.
Sure, yeah. Yeah, we should always go for alternate methods because you might figure out that method A is better than method B, and certainly
Right.
you may save a lot of time in solving using different methods. So let's
Yes,
look
definitely.
into the questions which you have selected. You can share the screen, right? So you can share the screen and we can go through your exam questions.
Okay. Can you see my screen, sir?
Yes, I do. Yes, I do. Yeah, yeah.
Cool. Right. Let's back a little bit. Was our last thing on circles, I feel like.
Okay.
No. So you have to get
No
rid of
problem.
this one. Sorry.
Yeah.
Oh no, okay. Here.
Okay, yeah. The circle thing we did last time, correct.
Right.
So here, can you please read the question?
Yeah. Okay, so given that log 3x equals a, find in terms of a log 3 9x and part b log 3 x to the power of 5 over 81. Giving each answer in its simplest form.
Right. So let's try to do it. So you are given that log to the base 3
Yes.
of x is equal to a, right? This is given to you. Find in terms of a, what is log to the base 3 of 9x, right? 9x. So basically, you have to use properties of log, right?
Right.
So when you say 9 times x within as an argument, it basically means it is log of 3 of 9 plus, or it is being multiplied, right? So log
Plus.
a times b will be log of a plus log 3 of x. Is that okay?
X.
Now,
Oh, yeah.
what is log 3 of 9? Log 3 of 9 is 3 square, right? We can log
Yeah.
3 of 3 square, right? So you can write in this term, and you're given log 3 of x is a. So you get a here. And using the power property of logarithms, you get this as 2, right? 2 plus a. Is that clear to you?
Yeah.
So that is how you could write the part A, which is log 3 of 9x. Is that clear?
Yes. So is the key thing about that one just writing it in the same, like just putting all the bases and trying to see similarities between, like obviously in this case it's 3, using 3 as the base.
So
Okay.
basically, we use logarithmic rules in this particular question. So it's kind of a review on the logarithmic rules. Perfect.
Right. Yes.
Now, the second one is the quotient rule. So in the quotient rule, when I have log to the base 3 of x to the power of 5 over 81. So this is quotient rule. So this will be negative, right? Log to the base 3 of x to the power of 5 minus log to the base 3 of 81. So that's the first step. Now we can apply the power rule here, and we can write this as 5 log to the base 3 of x. You can write the rules which you are applying on the side, minus log to the base 3 of what power of 3 is 81?
4.
4. So write that. So we have 5. Log 3 of x is given to us as a, right?
Yeah.
So we'll write this as a and minus. Here we have 4 log 3 of 3, right? So another rule will be applied here, 5a minus 4. Is that clear to you?
Yeah.
So we know that log a of a is 1, correct?
Yeah.
So using this, we can use this rule. And we also use the log rule that log a of b to the power of c is basically equals to c times log of a to b, right? So these two rules we have applied basically, right? apart
Yeah.
from the product and the quotient rule. Perfect. So this is clear to you?
Very.
Okay. Now, can you take up the next question? C, what
Yeah.
is C?
So,
Okay, C
sorry,
is
sir, I've got
combination
a
of the
major
previous
cough.
two. Okay.
It's not good. Okay, solve for x, where log 3 of 9x plus log 3 of x to the power of 5 divided by 81 equals 3, giving your answer to 4 significant figures.
So first part A, what result did you get? Log 3 of 9x. What result was there?
Plus a.
Can you please say it again?
Oh, sorry, 2 plus a.
And the second one, what did you get?
5a minus 4.
So here, because we are given log to the base 3 of 9x, which is part A, and second is part B. So we can rewrite this as 2 plus 9 plus 5a minus 4 equals to 3. Is that okay?
Oh, sorry, so the first part was 2 plus a.
A, not 9. Okay. A,
Yeah,
A,
that's
okay.
right.
So no, I wrote it incorrectly. 6a minus 2 equals to 3. 6a equals to 3 plus 2. And a equals to 5 over 6. You can simplify it. Is that clear?
Yeah.
Yeah. So that is how you'll do this part. Giving your answer to 4 significant figures. So now you have to find decimal value. Is that okay? So you can divide 5 by 6 using calculator and give your answer to 4 significant figures.
Wait, so we found a, but in this case, a was x, right? Or no?
Oh, okay, wait. We found A, you're right. We found A. Now we have to find X, correct?
Sub it back in or something.
So
Yeah.
you're right. So yeah, we'll rewrite. Good job. So log to the base 3 of X is equals to 5 over 6. So now we can say X is equals to 3 to the power of 5 over 6. Yeah, now use calculator to find the answer. Correct.
So 3 to the power of 5 over 6 is 2.498 to 4 significant figures.
To 4 significant figures. Is that clear? So that is how you're going to do this question and see how each and every question is related. And with this question, you've actually learned a good part of rules being applied for logarithms and also solving a logarithmic equation, simple equation.
Right.
Great.
Yes.
Is this concept clear to you?
Yes, it is.
So we can now take the next question.
Okay, so question 3. A company predicts a yearly profit of 120,000 in the year 2013.
Mhm.
The company predicts that the yearly profit will rise each year by 5%.
Mhm.
The predicted yearly profit forms a geometric sequence with ratio 1.05.
Yes.
Part A, show that the predicted profit in the year 2016 is 138,915.
Correct. So I like these types of questions. They actually verify your equation, correct? So
right. Yeah, the show ones.
Yeah, that's very good. So can you tell me how will you write the equation? We show that the predicted profit, so we are looking for profit, is so initial profit
is 120.
Whatever, right? Plus
the
rate is 5%. Basically means 1 plus 5%, right? So let me write like this, 1 plus 500, correct? And every year, so first year it is, after every year you can say predict yearly profit, show that the predicted profit in the year 2016, we are starting from 2013, right? So from 2013, and so that is n equals to 0, correct? After 1 year, company predicted yearly profit of this much in this year, so this becomes the P0 value. So n is 0 in this case. Is that okay?
Yeah.
So when you're talking about 16, then it is which year? 14, 15, 16 means
n equals 3.
So n equals to 3. So after every year, so
Yes.
so here the formula is n minus 1. You understand? If I write 1, or we will just write n. If you write 1, n as 1, that means after 1 year. Is it okay?
Yeah.
2 means after 2 years, 3 means after 3 years. Is
3
that
years.
So sometimes we use n minus 0, but now the thing is, this is after. So when it is after 1 year, n will be there, not n minus 1.
Okay.
That is very
Yeah.
important. So we get the profit as after n years will be the initial profit is how much?
120,000.
1,000, and that is 1.05 to the power of, and n
Right.
is 3. So we can plug in this value. Is it okay? And you can calculate. What do you get?
Yeah. You get 138,915.
138,915. So that clearly indicates that our formula is correct. So what is our formula? Formula is Pn, nth year is initial year times 1.05 to the power of n. And in our case, because Pn is 120, we can say Pn equals to 120,000, 1.05 to the power of n. Is that clear?
Yeah.
Now, part B, what is the question?
So find the first year in which the yearly predicted profit exceeds 200,000.
Yeah. So now we are given something which is more than. So we want this value to be more than 200,000. Is it?
Yeah.
And this value to be more than, and we want to calculate the value of n. So it is 120,000
divided
1.05 to the power of n. That should be greater than this.
Oh.
Right?
Yeah.
So
Yeah.
find the year in which. So this is what. So let's divide this, right? 1.0.
Wait, so
yes.
Just a quick question. How do we know that 2013 was the first year?
Yeah, because
Or like in a geometric sequence, we have A as being the first term. Is it just because it says in the year?
Yes. Starting
Oh,
from.
it doesn't have to explicitly say, because it just says predicts a yearly profit of 120 in the year 2013.
Yeah. So
how do I know it's the first? Oh, okay.
First year of profit. Yeah. The company was set up earlier, but this is earlier to this year, right?
Okay.
So it predicts yearly profit, right? Of this much in this year. So we'll call that at starting point.
Oh, okay. So you just assume that. Yeah.
0. So that is why I took time to define my variables. Do you understand?
Right.
So n is 0 at 2013. This is what I'm trying to say, right?
Mm-hmm.
This is my initial profit. So next year, again, it will be increased by 5%.
1.05. Yeah. By times in 5. Yeah.
You have to clearly say that. I could have used this as n equals to 1. In that case, my formula will be to the power of n minus 1.
Right.
Correct? First year profit, as you are saying now, right? First year, second year. But that will create a confusion because the question here is, show that the predicted profit in this year is so much, right? Anyway, either way you could have calculated. You could say, well, the first year is 2013. So 2016 will be the fourth year. So your formula will be n minus 1. So 4 minus 1 will give you 3, but you'll get this. So what I'm trying to say here, you could write either of those two formulas, but you have to define what is the initial value. Are you considering n as 0 or n as 1? Is it okay?
Yeah. Yeah.
Coming back to your question, when they say geometric series, right, I should have strictly started with n equals to 1, because when we say geometric series, we use 1, 2, 3, 4. We do not use 0th term. And that is why in geometric series, it is n minus 1. Is that clear to you?
Yeah.
So that's a good idea. So first year.
That's a good point.
That's a very good point. Yeah. So make a point. So I think what you should do here is that you should choose n as.
You should choose 2013 to be n as 1.
Yes. So let me rewrite this. Let me clear this. So we'll say year 2013 n equals to 1. Is it okay now?
Yeah.
We'll write. If that is the case, then the formula will be nth year will be the initial year, which is 120,000, 1.05 to the power of n minus 1. Is that clear to you?
Yeah.
So this becomes first year profit. We are saying so second year, third year, fourth year will go like this, right? So in that case, 2016 will be n equals to 4. Is that clear to you? So in the, which is the fourth year profit. So that will be equal to 120,000 to the power of 1.05 to the power of 4 minus 1. And as you calculated, it came out to 138,915. Is that clear to you?
Yes. Yeah.
Now, why did we do all this? Note. Let's make a note here, which is very important to understand. In geometric series, first term is n equals to 1. Is that clear? So therefore, you know, when we are talking about geometric series in the formula, we get n minus 1 as an exponent, right?
Yeah.
You're getting initial value, which I wrote earlier as P0, initial
Right.
value, as the starting point, as 0, right? Initial value. But
Yeah,
in geometric series, we explicitly say term number 1, term number 2, and therefore we have n minus 1. Correct?
Right.
We'll keep this in mind. Now let's go to question number 2, which is find the first year in which yearly predicted profit exceeds. That means we are now looking for this value of 120,000, 1.05 to the power of n minus 1 to be more than 200,000. Correct. So you can calculate this. You get 1.05 to the power of n minus 1 greater than 200,000 divided by 120,000.
Wait, so if we didn't do the n minus 1, would we have got a wrong answer for this part?
No, same answer.
Same
The only
answer.
thing is, yeah, well, once we are counting now, n equals to 1 as 2013. That is all.
Yeah. That's the only
Earlier we
difference.
were saying n equals to 0 is 2013, and we
Right.
were using n there. So either way, but you have to define what n is, correct? You're adding
No,
an-
I mean for part B, would it change the answer in any way or
no,
no?
it won't. It
For
won't.
part A, it's the same, but okay.
It will be same. It will be same. Yeah. So because we'll write year number, right? So 20 what? You get me?
Oh, okay. Yeah.
We know for n equals to 4, it is 2016. That means
Oh, I see.
Right.
Yeah. Same thing. Yeah. I just got it. I thought we were trying to find the value of n, but they're asking for find the
no,
first year.
you have to be careful. You cannot just see. This is the fourth year according to this, but when you write fourth year, it is
2016
plus 4 minus 1. You understand? To get that?
Yeah.
So you have to be more careful now. In my earlier calculation, n was the direct value, but now it is indirect. Yes.
Oh, I see. Okay.
There's a difference. So can you please calculate this? 200,000 divided by 120,000?
Yeah.
We'll just write 4, 5 decimal place.
5/3.
Okay, 5 over 3. That's good.
Oh, do you want decimal?
No, we don't want.
Oh.
So we'll now take log, right? So we get n minus 1 log of 1.05 or 5 over 3, correct?
Let me just do some
So
calculations.
n minus 1 is equal to log of 5 over 3 divided by log of 1.05, right? So we'll take 1 on this side. We'll add 1 to this. So what is the value of n?
Plus 1. 11.4698.
Okay. So more than 11 years, right? So we know it is the, so now getting back to our calculations, so more than 11 years, that means 12th year, correct?
Yeah, it has to be,
12th
yeah, because you can't have 11, and it has to be greater than,
12th year.
So 12
you can
years.
add, yeah, so it is the 12th year, right? So that means n minus 1 is the 12th year, the nth value. So our year will be 2013 plus 11, correct?
So yeah, 12 minus 1 is 11. So 2013 plus 11 is 2024. Yeah.
Now you substitute 2024 in your formula.
Oh, that formula of n minus 1.
No, n minus 1 we have to put 12. N minus 1 we have to put 12. But
oh yeah,
n minus n as 12 in the formula because you get 11, right? So use your formula and calculate 120,000 times 1.05 to the power of 12 minus 1, which is 11.
205,240.
Correct. That is what? More than 200,000. Is it okay? So
Yeah.
that is how you're going to do. And then I'll suggest once you do this, check solution. Check.
Right. Check answer. Oh, okay. There's a lot we learned in that one.
Yes.
Yeah.
So basically it is the 12th year, right?
12th year, yeah, is when.
Yes. And when you substitute, you get this. The year will be 2024. Perfect.
Right.
Now, so is this clear to you, Amy?
Yeah.
Absolutely clear, right? Okay. So let's take up the next question. I'll clear this out.
So part C, find the total predicted profit for the years 2013 to 2023 inclusive, giving your answer to the nearest pound. Oh, so do we use that geometric
sum of series, sum of series, right?
Yeah.
So your series now is 120,000. This is your term number 1, correct? And then R value is given A. This is A for you. R is given to you as 1.05. It is getting multiplied by this. And when you say 2013 to 2023, the number of terms will be how many? So if it is 2024, the numbers will be 2. Do you understand? So take away. So you do 2023, take away 2013, which is 10, and add 1 to this, right? Because when you do number of terms, do you understand? The first term is 2013 and 2014 will be the second term, but the difference is only 1, correct? But you have 2 terms. You get the idea?
Oh, okay.
Right? So when you do this, there are actually 11 terms in this series, right? So you're basically using NS11 to find the sum of the series.
It's because we're including 2013 to be the first term.
Both are included, since both are inclusive. Inclusive means you're including both.
Right.
So that means 1 more than the difference. Is it okay?
Yes, yeah.
Because, you could do all these mistakes, correct? Now, what is your formula? Sum of. So, Amy, do you understand? The value of n should be 11, right?
Yeah.
So now let's apply the formula. So sum of 11 terms is equals to A r to the power of n minus 1 over r minus 1. So it is A is given to us as 120,000. R is 1.05 to the power of 11 minus 1 over 11 minus 1, which is 10. Calculate this value. Yeah.
107. Oh, what?
No.
Okay, wait. 170. 4814.5.
Yeah, forget that point.
So nearest pound. So just
nearest one you'll have to round it. Yeah. 0.5, right? So you'll have to increase it.
It was 0.459.
Yeah. So it'll be 17048170481.5. Is it okay?
Yeah.
So that will be your sum, I think. So okay. So that is how you're going to do this geometric series sum. So you have to remember one part, that when we are talking about this inclusive, it means difference plus 1, because both are included, right?
Right.
And there are 11 terms in all. Perfect?
Yes, yeah.
Okay. So is this clear to you, Amy? Shall we move to the next question?
Okay. Yeah. So do you want me to just quickly summarize?
That'd be better. Yeah.
Okay. So what I learned from this question, so I thought it would be kind of straightforward, like looking straight at it, but it was kind of lengthier. Like even part 1 and everything, when we did it, it was all correct, and like what we did, the method was right, but just actually understanding other ways of like doing it. So when it says here, the predicted yearly profit forms a geometric sequence, because the fact that the question stated that, we decided to define our variables in terms of how a geometric sequence rules like are followed. So because the first term in a geometric sequence is always as n equals 1, we decided to make 2013 as n equals to 1 as the first year. So it didn't change any of our answers. It's just the fact that, when you write your original formula, we did n minus 1 because we started off 2013 as n equals 1. So just like that, we kind of followed through. So that was the first part. And then you just told me to like take your time to define the variables in the beginning, even though the question doesn't ask for it. It's just good to have that on the side so that when you have part A, B, C, and D, it's really easy to understand. And then from part C, we saw that the word inclusive was really important. Just like you said, sir, find the difference, but you have to add 1 because the first term, the both terms are included. So you have to accommodate for that.
Correct.
So, yeah,
Perfect.
that was that.
That's clear. So let's move on. Let's take the next question.
Circles.
Circle. So every year you get this question on circle, and this kind of pattern is being followed. So I think if you go through 4 or 5 of such test papers, you should do extremely well in your test.
Hopefully, right? Yeah. Okay.
Yeah. So can you please read this question?
Yeah. So the circle C has equation x squared plus y squared minus 20x minus 24y plus 195 equals 0. The center of C is at the point M, and part A, find the coordinates of the point M, and part I, the radius of the circle C.
Correct. So when they tell you to find both M and C, I'll prefer to do my completing the squares method and getting the answer for both. Right. Is it okay? However, Amy, now you know how to get the direct answers. I'd like you to find the center first. Tell me the direct answer. What value of C is the right answer? Tell me.
So you do minus 20x, which will divide by 2. So, and then switch the sign. So it'll be 10 and then 12.
Perfect. So you get the center. Amy has learned the method 2gx and 2fx. So you have to do half of it and change the sign. What we'll do completing the squares and see how do we actually do it, right? So let me show you the method quickly. Amy, can you please also help me while doing completing the squares? We have the equation x squared plus y squared minus 20x minus 24y. We'll take 195 to the right hand side. And here we'll rearrange our terms. We'll say x squared minus 20x. Yes.
I think it's minus 195.
Yeah, minus 1. Correct. So minus 20, half of 20 is 10. So we are going to add 10 squared and subtract 10 squared.
10 squared.
Now, on the other hand, we have, we have 24. Did I miss some term? Y squared. Yeah. Plus
y squared.
Minus 24y. Half of 24 is 12. So we'll add 12 square minus 12 square. And that is equal to minus 195. Clear?
Yeah.
Now, these 3 terms here form perfect square. Similarly, the other 3 terms form a perfect square. So we get x minus, because this sign is minus 10 whole square, plus in case of y minus 12 whole square. And those two minus 10 square and minus 12 square, I'm taking to the right hand side. So we already had minus 195. 10 square is 100 and 144 for 12 square. Is that clear?
Yeah.
So on the left hand side, you see we got the center as 10, 12. So we have verified the center. And this is square root of this will be the radius. So let's work this out. So x minus 10 whole square plus y minus 12 whole square equals to, Amy, can you do this? 100 plus 144 is 244. Take away 195. How much do you get?
49.
And 49 square root is 7. So we have r square as 49. And therefore, the radius will be square root of 49, which is 7. Is it clear? Yes. So we have answered both the questions. Center point being 10, 12, and the radius being 7. So r is, radius of the circle is 7 units, and the center point is 10, 12.
10, 12.
Perfect.
Nice.
Next.
Okay, so n is the point with coordinates 25, 32. Part B, find the length of the line MN.
Right. So we M to N. So M is the coordinate of
the distance formula.
Distance formula, coordinate of the point M, point M. So let me write center as M. That'll be better for me. So distance formula. So distance is equals to square root of x minus x1 whole square plus y minus y1 whole square. So use this distance formula. We can find distance mn. Distance will always be positive, square root of. We have the point given to us as 25, 32. So 25 is the x value minus 10 whole square plus 32 is the y value minus 12 whole square. Correct? So we have 15 square plus 10 square, 20 square.
Oh, plus.
Right?
Yeah. So square root of 625, which is 25.
So we get this distance as 25. Correct. So we've done this part. Now, the tangent, can you please read this part? Tangent to C.
C at a point P on the circle passes through point N. Find the length of the line NP.
So Amy, what did you learn today? Can you summarize your learnings?
Yes, so I learned a lot. So we kind of covered again a bit of circles, geometric sequences, and again a bit of the logs. So yeah, it was really good to see. So in this like question when we did it, we kind of learned about the way of going about it. So like just because the marks say 2 or 3 marks doesn't mean that the method that's followed that it would also be really, really short. Sometimes a lot of thinking has to go, but we did see how when we did the first method, it was obviously far longer than the one that we just carried out. So I didn't know this whole calculus method, and I definitely would not have used calculus for a circle, just because I know differentiation, everything's to do with gradients, but I didn't know that when you find the circle and then differentiate that equation, you get the tangent. So that was a really like important point. And just also keeping in mind the external point, you can have 2 tangents coming off of it. So you can have other parts to that question, part D, E, F, like saying, would there be multiple points? So just bearing in mind that is a good thing. And like we saw with the geometric sequence one, just keeping in mind the rules of geometric sequences, making n as 1, when in your head you want the initial one to always be 0. Sometimes you just got to kind of follow with the rules, make some links. So yeah, that was really, really helpful, sir. So thank you so much.
And since, I've seen many of your examples based on circles where there is an external point, and from there we need to find the length of the tangent,
right?
Which is a very lengthy question to answer. So if you look into my YouTube channel, just type out Anil Kumar external tangent application,
right?
Calculus with calculus external tangent, right?
Oh, okay.
You'll see so many examples where I've used similar methods to find the point P on the circle. So once you find point P, then you can do all rest of the things. Is that clear to you?
Oh, that's perfect. Yeah. So I'll definitely look into that. Okay. Thank you so much, sir.
Okay, then. All the best. Thanks.
All right. Bye, sir. Thank you.